Stratospheric ozone is formed by chemical reactions involving solar ultraviolet radiation. It separates the oxygen molecules and turns them into two oxygen atoms, which are highly reactive. The oxygen atoms react with oxygen molecules, forming ozone. Ozone is constantly being produced, but it is balanced by the destruction caused by chemical reactions of natural and human produced chemicals.
Ozone and oxygen molecules in the stratosphere absorb ultraviolet light from the sun, providing a shield that prevents this radiation from passing to the Earth's surface. While both oxygen and ozone together absorb 95 to 99% of the sun's ultraviolet radiation, only ozone effectively absorbs the most energetic ultraviolet light, known as UVC and UVB. This ultraviolet light can cause biological damage like skin cancer, tissue damage to eyes, and plant tissue damage. The protective role of the ozone layer in the upper atmosphere is so vital that scientists believe life on land probably would not have evolved and could not exist today without it. Ultraviolet or UV rays are a type of electromagnetic radiation. They have a shorter wavelength than visible light. They can be subdivided into three types: UVA, which is the longest of them, UVB, which is medium, and UVC, which is the shortest. Earth's atmosphere prevents most UV radiation from space from reaching the ground. UVC is entirely screened out by stratospheric ozone, while most UVA does reach the surface, but UVA does little genetic damage to tissues. UVB is largely responsible for sunburn and skin cancer, though it's mostly absorbed by ozone before reaching the surface. Levels of UVB radiation at the surface are especially sensitive to levels of ozone in the stratosphere.
Ozone is what is known as a trace gas, meaning there is very little of it in the atmosphere. Out of every million molecules of gas in the atmosphere, less than 10 are ozone. Ozone is measured with Dobson units. A Dobson unit of gas is equal to a layer of gas at the surface of the Earth, with a thickness of 1/100th of a millimeter. The ozone is the atmosphere in about 300 Dobsons. That means if you brought all of the ozone in the atmosphere down to a layer of pure ozone at the surface, it would be about 3 millimeters thick. And much of the ozone is located about 20 kilometers above the ground, in a part of the atmosphere called the stratosphere. This is why it is called the ozone layer.
Threats: ozone depletion. Stratospheric ozone is threatened by chemicals that react with the ozone and reduce its concentration. These chemicals are collectively referred to as ozone depleting substances, or ODSs, and often contain chlorine or bromine. Chlorofluorocarbons, or CFCs, are one of the main groups of ODSs. Ozone depleting substances. ODSs often contain chlorine or bromine. Chlorofluorocarbons, or CFCs, are one of the main groups of ODSs. Examples include triochlorofluoromethane and chlorofluoromethane, sometimes referred to as freons. These are used as coolants in refrigerators and air conditioning systems, propellants in aerosol cans, cleaning agents for electrical parts, and blowing agents in plastical foam. Other ODSs are methyl bromide, which is used as a soil fumigator to eradicate pests. Natural sources include emissions from the ocean and the burning of biomass. Halogens are similar to chlorofluorocarbons, but contain bromine instead of chlorine. They are used as fire suppressants in fire extinguishers. Hydrofluorocarbons, which have similar properties to chlorofluorocarbons and contain either or both bromine and fluorine, they are used as solvents, cleaning agents, and as suppressants in fire extinguishers. Carbon tetrachloride is used as a solvent, dry cleaning agent, refrigerants, and as a propellant for aerosol cans. Methyl chloroform is used in industrial solvents, degreasing agents, correction fluid, spray adhesive, and in aerosols. Finally, natural threats include emissions from volcanoes.
Flight observations started in 1912 in the Antarctic, but it was not only after 1956 that the British Antarctic Survey set up the Halley Bay Observatory on Antarctica, in preparation for the International Geophysical Year of 1957. In that year, ozone measurements using a Dobson spectrophotometer began. Said observations showed the first signs that there was something wrong. Experiments started taking place in order to determine the possible causes, dangers, and size of the hole. Polar stratospheric clouds have a very important role in Antarctic ozone destruction. These clouds support chemical reactions that produce active chlorine, which catalyzes ozone destruction, and also because they remove gaseous nitric acid, perturbing nitrogen and chlorine cycles in a way which increases ozone destruction.
The Montreal Protocol is an international treaty that was signed in Vienna Convention in 1987 in order to protect the ozone layer by reducing hazardous emissions that deplete the ozone in the stratosphere, with the principal goal of phasing out the compounds containing chlorine and bromine partially or completely. It was the first universally ratified treaty, being signed by all 196 parties and the European Union, even when there was only 14 years since the discovery of the issue, and there was only basic research about its effects. As more information is available, the protocol set up new targets accordingly, aiding developing countries through the Oxygen Action Program with IVIs and multilateral funds so they can reach the goals too.
Gracias.